This apparatus is designed to levitate a pair of spinning tops for sustained periods of time, measured in hours or even days. To achieve this, it uses large permanent ring magnets to provide an upward force on each spinning top that exactly balances the downward force of gravity. Each top contains a powerful disc magnet made from the rare earth element neodymium, and this magnet repels the magnetic field from the base, thus giving it lift. However, this is a potentially unstable situation, as the magnet in the top will try and flip over and fall downwards. This is where the spinning comes in. Each top acts as a gyroscope, which continuously corrects itself if it starts to topple, just like toy gyroscopes that can be balanced on the end of your finger or on a stretched wire. Each top is initially spun up to a high rotational speed using a converted coffee whisker, and then carefully lifted into the balance point, which is about 5 centimeters above the base magnet. The tops will remain levitated for 3 or 4 minutes until air resistance eventually slows them to a point when they topple over. We want the top to spin indefinitely, so how can power be delivered to the top so that it maintains its spin? The design of these tops include the use of metal and fibre washers that are loosely fitted such that they can adopt different positions about the axis of the top while it is spinning. This means that the top wobbles at a high frequency and that the magnetic axis of the top is no longer aligned to its axis of rotation. This is where the coil in the centre of the machine comes in. It is powered from the mains via a step-down transformer that delivers 12 volts AC at 50 Hz. This produces a magnetic field that oscillates at 50 times a second. The position of this coil is such that the magnetic lines of force are approximately horizontal at the points in space where the levitated tops are located. It is the interaction between this oscillating magnetic field and the off-center magnetic field of the magnets in the spinning tops that delivers sufficient torque to overcome the drag of air resistance. Each top asynchronously locks onto a particular rotational speed, which is less than the 50 Hz drive frequency which is sustaining the spin. Once settled, the top's rotational speed is then extremely stable. A variable strobe light was used to measure the rotational speeds of different tops, and they were found to lie in the range 32 to 42 Hz. The strength of a magnetic field from a permanent magnet is very sensitive to changes in temperature and decreases as the ambient temperature rises. Given the delicate balance between the magnetic lifting force on the tops and the gravitational pull downwards, small changes in temperatures will cause the tops to fall. To overcome this problem, small nylon washers can be added or removed from the top to alter its mass until equilibrium is restored. This is extremely inconvenient, so a better solution has been found. Each base magnet has a coil wound around its circumference, which is powered by a variable DC current. This means that the coil acts as an electromagnet, which can fine-tune the lifting force provided by the base magnet. The controls to vary the current in these two coils on the apparatus can be seen here on the front panel. Once the tops have been spun up and positioned above the lifting magnets, they will rotate stably. However, over time they can develop a low frequency wobble or start to bob up and down. By placing discs of non-magnetic metal directly under each top, these perturbations can be greatly reduced as the eddy currents that they induce in the metal discs dissipate the energy. I've chosen to use large commemorative metal medals as damping discs as they're more pleasing to the eye. This apparatus makes use of an oak baseboard and brass fittings and embellishments, echoing the style of the experimental equipment used by Faraday and other pioneering physicists in their lectures to the Royal Institution during the 19th century. To end this experiment, I can simply pluck a top from its position, or I can turn off the electromagnet which is providing additional lift, and it would fall into my hand.